Right, guys, welcome to my YouTube channel. You are still watching ETH. This is the channel whereby we bring you the best in maths, physics, and chemistry. Now, guys, if you haven't subscribed to my YouTube channel, please do so. And also don't forget to click the notification button so that you can get more content as we progress. Now, today, I'm going to teach you guys a very interesting topic in maths. I hope everyone is ready for this one. Guys, today I'm going to teach you guys Euclidean geometry. Euclidean geometry. One of the most fascinating topics in maths. All right, Euclidean geometry. Euclidean geometry. Right. Now, what is Euclidean geometry? This is the mathematical study of shapes and the mathematics behind those shapes. Geometric. This comes from metric. Geometry, metric, which means maths or anything that has to do with calculations. Now, like geography. Geography is a study of the earth shapes. So this has to do with shapes, right, guys? Without wasting your time, we're just going to be explaining theorems. So I'm not going to do any examples in this exercise. So the first theorem we're going to look at is this theorem. Now, what we know is that if two triangles that has a common angle within two perpendicular height, within two parallel lines. It means they have the same height. Now, what we know is that this means that triangle A, B, D, and triangle A, B, D have the same altitude or height. Okay, now the reference to this theorem is the same parallel line. Therefore, same angles. Now, another theorem. Hey, sorry guys. I think that's perfect. Okay. Now, what we know, let's say this is A, B, C, D. What we know about a polygon ABCD is that the triangles with the same base between two parallel lines have the same area. That should be true because area is given by half base times height. So if the base is the same and they lie between two parallel lines, it means the height is the same. Therefore, what we know is that triangle ABD, the area of triangle ABD is the same as the area for triangle ACD. I hope you will agree with me. Now, when you're proving, this is the reference that you're gonna use. The reference is same base, same height. Right. Now, we're gonna move into so-called proportional theorem. Also, we are talking about triangles. This is a theory on triangles. Now, according to the proportional angle, to the proportional theorem, what we know is that if you have two parallel lines, if you have two the theorem states that if two triangles are equiangular, they are similar, and the sides are proportional. Okay. Okay. So what we know is that these two angles are the same. These two angles are the same. And the two triangles, the bigger one and the smaller one, they share common angle. So it means these two triangles are similar. Reason, and triangle A, B, C is similar to triangle D, B, E. Reason, angle, angle, angle. The angles are the same. Okay. Now, what we know also is that if you divide the area of A, B, A, B, C, if you divide it by the area of if you divide the following side, if you divide AB divided by BD, it will be similar to CB divided by BE. Guys, if you don't understand, please go to the comment section and ask questions. Yes, that's what we know. And these two ratios are the same. The other ratio that we're gonna compare with, this is also equals to AC divided by DE. Now, guys, that's what the theorem entails. Okay, so we're gonna move on to another theorem. That theorem is called the third angle of the triangle. Third. Now, normally when you give reference to this theorem, you will say, I forgot. You have to say proportional theorem. Proportional theorem of a triangle. Right. Yeah, we now have this theorem, third angle of triangle. Now, I'm gonna give a very nice example. So what we know about the third angle is that if you have a triangle like that and you draw a height on the triangle, this angle here will be equal to that one. It is very easy to prove it. Now, if you want to prove it, what you know is that all these angles now, we still need to find out more about this theorem. There's few things that I need to tweak because I'm trying to think about it. But I'm going to come back to that theorem or I do a special video. Okay, let me move on to theories of circle geometry. All right. With circle geometry, the first theorem I'm going to start with is this theorem. And now what we know is that perpendicular bisector of a chord is what we know, what we know is that a radius that bisects the chord is perpendicular to the chord. It's perpendicular to the chord. Okay. Each and every time if you draw a radius that bisects the chord, it is always at right angle. Second theorem, we have the following situation. Guys, I'm not that good with drawing circles, but I will try. Where I can, I will try. All right. Now, guys, if you have 2 points, point A and B, if you draw a line to the circumference of the circle from A and another one from B, and they join together, and you draw another line from the same points going to the center, what what we have found out is that this angle is actually half this angle. So what we know is that the angle subtended from the arc to the point, to the center, is twice the angle subtended from 2 points to the circumference. So the reference is that the angle subtended to the circumference is 2 times the angle subtended to the center. Okay, that's the reason that we give all the time when we are proving that theorem. Okay. Number 3. What we know is that the angle subtended by the diameter is 90 degrees. We have this situation. If I draw a diameter, if I can draw a line to the circumference, then back to the other end of the diameter, that angle there is always 90 degrees. So angle subtended by a diameter this is the diameter, by the way. That's the angle subtended by the diameter. It is 90 degrees. So guys, on all the theorems that we are coming up with, you must master and you must cram the structure, because you're always going to get the structure when they ask you to prove. Now the reference will be angle of a semicircle, or you can use angle subtended by a diameter, or you can use angle of a semicircle. It's the same thing. Now, number 4. We have the following. Okay, this is the center. Now, what we know is that if a line segment subtend equal angles at the circumference, then the angles on the same segment will be equal. Now the thing is, if you draw a circle and you have this structure, you will know that this angle and that angle are the same, and that angle and that angle will be the same. So the reference will be angles in the same segment. If you want to check where the segment is, this portion, this is a segment. And this one is also a segment. Now, a segment, it can be the area on the other side of the center, which is within the chord. That is a segment. Now, there's two segments. There's that segment and that one. So these two angles are the same, and that one are the same. These are angles of the same segment. Right, thanks. Now we go to number 5. Now with number 5, we have a very simple theorem. What we know is that the opposite angles of a quad are equal. Now the reference, the opposite angles of a cyclic quad, Cyclic quad, is a quadrant within the circle. Quad, okay, sharp. Then number 6. We have the following phenomenon. Guys, if you can cram all this theorem, please do so. If I extend the line there, what I know is that these two angles are the same. Exterior angle of cyclic quad is equal to the interior opposite angle. Okay, now the reference is also simple. Use the exterior angle of the cyclic quad equals to the interior. That's it. Then the seventh theorem, what we know is that tangent of a side of a circle is perpendicular to the radius at a point of contact. Tangent of a circle is perpendicular to the radius at an point of contact. Okay, now the reference is tan perpendicular to the radius. Right. Number 8, we have this theorem. Okay. Okay. Two tangents drawn from the same point, in this case, point B or point A. Same point outside the circle. They are equal. They're equal. So now the reference will be tangent drawn from same point. Okay, that's it. Now, all right, we have number 9. There's also a very interesting theorem. Okay. Okay. Now, what we know is that this is A, B, 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 E. What we know is that angle DAB is equal to angle BCH. The reason is that the angle between a tangent and the chord. This is the tangent and this is the chord. Drawn from the point of contact is equal to the angle at the alternative segment. Now the reference to this one is alternative segment theorem, or tan chord theorem. So we're also going to talk about congruency, which I'm not going to touch much about it, but what we know about congruency is that congruent triangles are equal in everything. So normally, if you want to give the reason for congruency, if you can prove that angle, the side and the side and the side are equal, then you've proved congruency. Or if you have proved that the angle and the angle and the angle, actually, if you have proved that all the angles are the same, and at least one of their sides equal, then you've proved congruency. All right, guys. Now, thank you for being part of this lesson. And if you haven't subscribed, please do so and click the notification button for more content. Guys, I'll see you on the next one. Thanks.